Good morning students. We are studying chapter gravitation in which we learn universal law of gravitation. What is the universal law of gravitation? We know that every object in the universe, here the universe, not only on the earth, every object in the universe exerted some force on the other object, exerted some attraction force on the other object, which we can calculate by using the formula, that is F is equal to G m1 antagonist. This is the, you can say R or you can say it like D, this one. Where m1 acts the mass of the object and then D is the distance between their centers. So we can calculate the force of attraction between the object by using this formula. So we have learned this formula in the part universal law of gravitation. Now we know that every object in this universe are attract each other. So I ask one question from you, that if every object attract with the same force, like this is the earth, and suppose apple, we drop an apple from a height, it always moves towards the earth. Why earth does not move towards the apple, though both of them have the same force of attraction? So we can find it, like we know that F is equal to m into a. By the Newton's second law, we have learned in the second chapter of physics. F is equal to m into a is the force acting on any object. So it means we can also find the acceleration by using the formula A is equal to F upon m. It means the acceleration produced in the body is not depend on the force, but also depend on the mass of the body. So it means this is the earth and this is the apple, and it is moved freely towards the center of the earth because the acceleration produced in this apple is high, is very high as compared to the acceleration produced in this earth. Since both of them have the same force of attraction, but the mass of the apple is so less, due to this the acceleration produced in the body in the apple is high. So, and the mass of the earth is so large, the earth has a huge mass, so the acceleration produced in the earth is negligible. It means due to the mass of the earth and the apple, the acceleration produced in the apple is so high as compared to the earth, because earth is so large and it has a very huge mass, so the acceleration produced in the earth is so less. Due to which the apple always moves towards the earth, but not earth move towards the apple. So I asked you this question in last video. Again I answered this question. Now let's talk about the free fall. Topic is free fall. So now we are going to understand what is the meaning of free fall. If you drop something from a height, like this is a small chalk, and we drop it from a height, then what happened? This apple chalk moved towards the earth because earth exerted a force on this chalk, due to which the acceleration produced in the chalk and it moved towards the earth. So if a body moves towards the earth in which the acceleration produced in the body is due to the force exerted by the earth on the body, is called the free fall. It means if an object moves towards the earth under the force exerted by the earth on the object, is called the free fall. So it means there should be no any other external force in the body which is moving downwards. So it has only the one force which is exerted by the earth. So this type of fall is called free fall. Okay. So this is the free fall. If something moves towards the earth and the velocity of the body is going to be increases. If we drop something from a less height, suppose we are here at the top, and the height of this top is it is h, and your friend is here at the height of h upon 1 and a half of it. And imagine if he drop a stone from here and it hits the ground, a ball. He drop a ball. When he drop a ball, the ball will reach the ground with a certain velocity. This ball will have some velocity. they reach the ground? Again, just imagine. Just imagine that if you are going to drop the ball from the height edge, twice the height from which your friend dropped the ball. Just think about it. Both the ball will have the same velocity when they reach the ground? No. You know? Obviously no. This ball will have less velocity and this ball which we drop from the large height will have the large velocity. It means the velocity is going to increases as we increase the height. If the velocity of the body changes, we can say that it has an accelerated motion. So we can say in a ball the acceleration produced. This acceleration is produced to the earth because earth exerted force on the ball. So the acceleration produced in a body due to the force of attraction which is exerted by the earth on the body is called the acceleration due to gravity. Acceleration due to gravity means the gravitational force which is exerted by the earth on the object. Acceleration due to gravity. Acceleration due to gravity. So acceleration due to gravity means the acceleration produced in a body due to the gravitational force exerted by the earth is called the acceleration due to gravity. Again I am telling you, the acceleration produced in a body due to the force exerted by the earth on it is called the acceleration due to gravity. Since the acceleration is produced by the gravitational force exerted by the earth, so we can say the acceleration due to gravity. We represent it by using the symbol g, small g. Small g is the symbol for the acceleration due to gravity. There is a large difference between the small g and the large and the big G. Small g and this capital G. The small g and capital G has a huge difference. You should also understand what should be the difference between these and this is small g and the capital G. This is a very good question. Then differentiate between the small g and capital G. So acceleration produced by the earth in the body. The acceleration produced in the body due to the gravitational force exerted by the earth is called the acceleration due to gravity. Will represented by the symbol small g. Like all other acceleration represented by the SI unit of meter per second square, all the acceleration having the unit of meter per second square. So same as this acceleration due to gravity having the same SI unit, that is meter per second square. So it has the unit meter per second square. Okay. So this is the acceleration due to gravity. Now let's talk about it in detail. Now just imagine. Suppose you are at your terrace and you drop two objects. One is a heavy stone and other one is a light feather. And you drop both objects from your terrace. Just look at here. And what do you think? Which will comes first at the ground? Obviously the stone. Yes. So it was thought that initially it was thought that every object will reach the ground at the same time. If we drop a heavy object or a lighter object, both will reach the ground at the same time. It was earlier thought. After some time, a scientist, Galileo was a scientist who discovered that the object, either it is heavier or it is lighter, will reach the ground at the same time. He do experiment. He dropped some objects from the Leaning Tower of Pisa. Yeah. He dropped the object on the Leaning Tower of Pisa and he found that both objects reached the ground at the same time. And he is surprised to see that why both objects reached the ground at the same time. He was the first scientist who showed that every object, either heavier or lighter, will reach the ground at the same time. It do not depend that the acceleration produced in the bodies do not depend on the mass of the body. It means a heavy stone or light feather should reach the ground at the same time. It do not depend. The acceleration produced when they reach the ground, they will have some velocity. It means the velocity is going to be changes. It means it has an accelerated motion. So acceleration produced in the body do not depend on its mass. The first scientist who discovered it is name was Galileo. So now this is the question. If we drop a stone and a feather from the roof, from the terrace, then why they drop? Why the stone first come first on the ground and why the feather comes late? So yeah, we can understand it. Since there is an atmosphere around us, atmosphere has air, and air will have some resistance. So due to this resistance, the stone, since it is so heavy, the resistance by the air on the stone is less as compared to the resistance by the air of the feather. So it means the feather will have a less resistance. It will experience a less resistance as compared to the stone. Since the stone having the large mass, this is a stone and this is a feather. So the resistance of the air will exert it, the large resistance will be exerted on this feather since it is lighter, and the resistance of the air on this stone will be less since it has a high use mass, large mass, not the use, large mass. So due to this resistance of air, this feather come to the ground first. This stone come to the ground first and later the feather. Okay, if it is possible, then you can do this experiment in vacuum. I know it's not possible. We can't create a vacuum in a room or in an atmosphere anywhere. So if can we do an experiment? If we are able to do an experiment in a vacuum, vacuum is when there is no air. So if we do this experiment in a vacuum, we will surprise to see that the stone and the feather will reach the ground at the same time because there is no resistance of air. It means the acceleration produced in the stone as well as on the feather is same, is equal. So this acceleration produced in the body is called the acceleration due to gravity, since it is produced by the gravitational force of the earth. Okay, so now let's calculate the value of G. The value of G is 9.8 meter per second square. And now we are going to find out by calculation why the value of G is 9.8 meter per second square. So you can imagine that if you are going to drop some object from the height, the acceleration produced in every object will be equal to 9.8 meter per second square. It does not depend on the mass of the ball. So now let's try to calculate the value of small g. And this is a question from my side. Find out the difference between the small g and the capital G. Small g means the acceleration produced due to gravity, and capital G is the universal gravitational constant. So you will find out the differences between them. So let's calculate the acceleration due to gravity. So let's take one example. This is the earth having the mass m. I am representing the mass of the earth by m. And having the radius of r e. And an object which we are going to draw. In which we want to find out how much force of attraction are acting between the earth and the object. So the object having the mass m. This object is free to move towards the earth under the gravity of the earth. So if we draw this object on the earth, so let's try to find out the force of attraction between, what is the value of the force of attraction which is acting between them. So we know that according to the universal law d square, where d is the distance between the center of the earth, center of the two objects. So let's try to put these values here, the values of m1, m2 and the distance here in the formula. So let's apply the formula of universal law of gravitation. So first you will write that let the mass of the earth is m and the mass of the object is m, and let the radius of the earth is r. Okay, let's one more thing is, what should be the distance between the center of the earth and the object? Since the earth has a very huge radius, so as compared to this radius, the distance of the object from the surface of the earth is near about negligible. So we are going to neglect it. Let's neglect it. And we can say, according to the universal law of gravitation, the force of attraction which is acting between the earth and the object is equal to G. M1 is the mass of the earth, M2 is the mass of the object, upon the distance between them is R e square. So again I am going to tell you why I am taking it RE, radius of the earth. Since the distance between the surface and the object is negligible as compared to the radius of the earth, so we are taking it like RE. This is the distance between the earth and the object. So, okay, so this is the force. Now just think, if an object is going to drop on the earth, it will have some acceleration. So we are going to represent the acceleration by g, small g. And according to the Newton's second law, we know that the force is equal to m into g, mass into acceleration. So if we want to find out the acceleration on this object, then we have to put the value of the mass of this object and the acceleration produced on the object. So F is equal to m into g according to the Newton's second law. Again I am going to tell you that if you are taking the force exerted on the object by F, then we know that according to Newton's second law, F is equal to m into a, where a is the acceleration produced by the force. Now in this case, the acceleration produced in the body is due to the gravity. So we are representing it by g. And this is the mass of the object. So this is the mass of the object and this is the acceleration produced in the object. So let's put the value of F is equal to m into g here. We will get F is equal to m into g m upon r square. So we can cancel out m and m. What will we get? It will be g is equal to g me upon r square. So this is the derivation of g, where you will say that m is the mass of the earth and r is the radius of the earth and g is the universal rotation constant. In this formula, is the mass of the object is present? No. It means the acceleration produced in the body depends on the mass of the earth and the radius of the earth and the universal rotation constant, but not on the mass of the object. So we can see the acceleration produced in a body do not depend on the mass of the body. It only depends on the mass of the earth as well as the radius of the earth. So we can also calculate this value by putting the values of mass of the earth and radius of the earth. We know the value of g, the value of acceleration due to gravity is 6.67 10 to the minus 11. So we are going to put this value here. G is equal to 6.67 10 to the minus 11 into mass of the earth. I have to see the mass of the earth. 6 into 10 to the power 24. 6 into 10 to the power 24. This is the mass of the earth. And the radius of the earth. It is equal to 6.4 10 to the power, I think 8. Let me see. 6. The radius of the earth is 6.4 into 10 to the power 6 meter. This is the radius of the earth. You always represent radius by using the unit meter, not kilometer, because the SI unit of length is meter. And d square, r square. So what we have done? We put the values of g, m and r. After calculation asked. Even though this derivation can be asked, which we use for finding the acceleration due to gravity. So question can be, what is the acceleration due to gravity and how can we find it? So you have to explain all these things for finding the acceleration due to gravity. So I think we should do some numerical which are based on acceleration due to gravity. Okay, before going to the numerical, I am going to explain you on which factors this acceleration due to gravity depends. It means, is it equal on this earth? Is it equal means this is the earth, this is pole and this is called equatorial line. So is the acceleration due to gravity on the pole or even on the equatorial line is same? So let's discuss it. Okay, you can write all these things in your notebook. You can pause this video for writing answers. So now let's talk about how the value of G varies on this earth. We know that the radius of the earth is not equal everywhere. We know that the earth is not spherical, total spherical, it is flat. Like this. It has a shape like this. It is not spherical as we imagine. It is somehow flat. So it means the radius and the pole. This is the radius of the pole. I am representing it by RP. And this is the radius of the earth. Equator. I am representing it by RPS. RP representing the radius of the pole and RE representing the radius at the equator. Now, this radius of the pole is less as compared to the radius of the equator because it is flat. And according to the formula, we know that G is equal to G ME upon RE square. Here the mass of the earth is not changing. The G is also not changing, but the radius is changes. As G is inversely proportional to the radius of the earth. So it means by increasing the radius, we can decrease the value of G. If the radius of the pole is high, equator is higher and radius of the pole is less, so we can say the value is if the radius is less, the acceleration produced will be higher, and if the radius is large, the acceleration produced will be less. So the acceleration produced at the pole, this is G, the acceleration at the pole, is higher than the acceleration produced on the equator. So acceleration produced on the radius of the earth. Since the radius of the earth vary at the pole and the equator, so we can say the acceleration is also vary. Which having the less radius will have the large acceleration produced, and which having the large radius will have less acceleration produced. So just think about it. If we drop something, we are dropping something from a long time from starting. So again, because it is not the free falls, so we are going to drop something. So let's drop two objects, one on equator and one on pole, and just think and then answer me. I am not going to answer this question. On which part, like on the pole or either on the equator, on which part the object will reach first? If we drop something from a particular height, equal height, one on the pole and one on the equator. So in which part the object will reach first? It means it will take less time as compared to the other one. आप यहाँ पे कुछ फेंकोगे तो जल्दी नीचे गिरेगा या यहाँ पे डालोगे तो जल्दी नीचे गिरेगा. So you have to answer yourself. I'm not going to answer this question. So yes, I was talking about on which factors the acceleration due to gravity depend. So first one on the radius it will also decreases. In the first case, the acceleration will decreases if we move in higher, if we move away from the surface towards the altitude, the acceleration will be decreases. Same as we move towards the center of the earth, the acceleration produced in the body will also decreases. So in both the cases, the acceleration will decreases. Either we move away from the surface or we move under the surface of the earth, that is towards the center of the gravity, towards the center of the earth, towards the center of the earth. So the value of G is highest at the surface of the earth. So one thing you should know that. So it is maximum at the surface of the earth. So these are the factors on which the acceleration of the body depends. Let me check. Is there another value? Okay. So now next, do some numerical of acceleration with gravity. You know, starting 4 chapters of physics are based on the numericals, or seriously they are based on the first chapter. So we are going to use this formula G is equal to G m upon r square, and we are going to do some numerical. So you will write in your notebook that what are the factors on which the acceleration of gravity depends. This is the numerical. Calculate the value of acceleration due to gravity. So first I told you that you should write the values which are given in the question. You have to find the G, value of G on the surface of the moon. So you have to find the value of G on the surface of the moon. It is given that the mass of the moon is equal to 7.4 10 to the power 22 kg. 7.4 10 to the power 22 kg. This is the mass of the moon. And the radius of the moon is 1740 kilometer. This is the radius of the moon. Now we should also take we have to take this radius in meter. So we will convert it into meter. We can write it like 1.7 10 to the power 3 and 30,000 kilometer. 10 to the power 6. This is the radius of the earth. Sorry, moon. देखो 3 0 यहाँ पीछे चला गया पॉइंट 1 2 3 यहाँ आ गया और किलोमीटर को मीटर में कन्वर्ट करेंगे तो वी हैव टू मल्टीप्लाई बाय 1000. So 1000 मिला के 10 power 6 meter. Now for finding the G, okay, now we have all the values of mass, radius and G. So capital G 6.67 10 to the power -11 into m1 7.4 into 10 to the power 22 upon radius 1.7 10 to the power 6 whole square. So you can calculate it by taking all the numerical value aside and the powers aside. 6.67 10 to the power, sorry, 6.67 into 7.4 upon 1.7 into 10 to the power 11, 10 to the power 22, sorry, it's -11 upon 10 to the power 6 to the 12. So you will calculate yourself, and by this you can find the value of G. It is 1.63 meter per second square. You know, what is the relation between the gravity, acceleration of gravity on the moon and on the earth? Let's calculate G on the earth and G on the moon. G on the earth is 9.8 and G on the moon is 1.67. Is it? 63, okay, sorry, 63. So it is near about 6 times. Near about, not exactly, 6 point something. So 6, near about 6. So G on the earth upon G on the moon is equal to 6, and G on the moon come in multiplication with 6. So we can say G on the moon is equal to 1 upon 6 times the G on the earth. This is a relation on the acceleration produced on the earth and on the moon. The acceleration produced on the moon is 1 upon 6 times the acceleration produced on the earth. You have seen in some videos that the astronauts which foot on the moon moves like they are jumping, because the acceleration produced in the moon is so less as compared to the earth. So the weight they feel is also so less. The weight is dependent on the G. We will talk about it later. So now you will do some numerical of this chapter yourself, and in next video I will explain you equations of motion for Finley polynomial. Okay? Then continue your study. Bye.